Welcome back to my series Best Helping Hand for JAMB 2021. Thank you for watching the past video. If you have not subscribed to my YouTube channel, please do, so that you can get the latest notification on the videos that I'm going to be uploading to, so that you can also be notified anytime I am solving past question live. So I can't be solving past questions and sending the video. I can only teach and later solve past questions. So when I want to solve past questions, it's going to be live, so that you can be notified when I want to solve live past question. So thank you very much for following. In the previous class, we've talked about resolution of vectors and blah blah blah. If you have not watched them, please go back and watch the previous video. And this is not all we'll be solving on equilibrium. We still have 2, we have 3 where we'll be solving some concrete example. Please stay tuned and watch all this series to the end. Thanks so much. In this class, we'll be talking about the definition, the types of equilibrium based on its virtue and based on its stability. Then we'll talk about center of gravity. Then lastly, we'll talk about the principle of equilibrium. Definition: when is a body said to be in equilibrium? A body is said to be in equilibrium if it does not rotate or it does not accelerate. So a body is said to be in equilibrium if it does not rotate and if it does not accelerate when it is moving on a straight line. So that body is said to be in equilibrium. So types of equilibrium, I said based on their virtue. So we have what is referred to as static equilibrium, and we have what is referred to as dynamic equilibrium. So what is static equilibrium? A body is said to be in a static equilibrium when it is stationary, when it is standing like this. That is, it's not moving. For it to be moved, you need to apply a force to it to make it to move. So if it is standing still, we said it's in static equilibrium. Then we said it is dynamic equilibrium if it is in constant velocity on a straight line. That is, it is moving with constant velocity on a straight line, then we say is in dynamic equilibrium. Static equilibrium if it is stationary, dynamic equilibrium if it is moving on a straight line with constant velocity. If it is moving on a straight line with constant velocity, we say is in dynamic equilibrium. Then based on its stability, we have 3. Based on stability, we have what is called stable equilibrium. In stable equilibrium, a body is said to be stable in stable equilibrium if it is slightly displaced and it returns back to its original position. If it is slightly displaced and it returns back to its original position, we say that body is in stable equilibrium. So I will bring an example for you to see. When you have this body, when you slightly displace it, it returns back to its original position. It's said to be in stable equilibrium. When you slightly displace it and it returns back to its original position, it's said to be in stable equilibrium. Unstable equilibrium: when you slightly displace it and it changes its position, it is said to be in unstable equilibrium. That is the second one, unstable equilibrium. Unstable equilibrium, do you see it? It's stable like this, as in standing still like this, is in equilibrium, it's not moving. But when I slightly displace it, you see it, what happened? It changed position, so we say it's unstable equilibrium. Then the next one is said to be neutral equilibrium. Neutral equilibrium is when you slightly displace it and it continuously change its position. So did you see it? when you just displace it a little, it continuously change its position, then you say it's in neutral equilibrium. So we can see that. So neutral equilibrium, if you displace an object and it continuously change its position, is referred to as neutral equilibrium. So we've talked about stable equilibrium, unstable equilibrium, neutral equilibrium. So what are the conditions for making a body to be in stable equilibrium? One, its center of gravity must be closer to the ground. Don't worry, we'll discuss center of gravity later. Its center of gravity should be closer to the ground. So if this is the body, the center of gravity, once it's closer to the ground, that body will be in stable equilibrium. That is the condition number one. The condition number two for you to have stable equilibrium is the base which it is standing. If it is having a very big base, the base which is standing, if it's very big, then it's going to be stable. So let's assume that this, so if you displace it, it can still sit back on that base. So the second position is talking about the base. For unstable equilibrium, its center of gravity is at the top. Its center of gravity is at the top. So when slightly displaced, the center of gravity will pull it down. So that is for unstable equilibrium. So that is the condition number one for it to be in unstable equilibrium. The center of gravity of the object must be close to the top. Then the condition number two for it is the base which it should be sitting on will be very small. So that is why when we have this small place serving as the base, any small displacement, we see that the body can fall and change its position. So the base on which it's sitting must be very small. So that is why we can see even this biro is having, this pen is having a very small base. So if we manage to stand it to be in equilibrium, any small displacement, any small, you see it will fall. Why? Because the base on which it was sitting is very small. The neutral equilibrium, condition number one for a body to be in equilibrium is the what is it called? The center of gravity must be at the middle. Center of gravity must be at the middle. Then two, it must have a circular surface. It must have a circular surface. So when it has a circular surface or spherical surface, just a little displacement, it will start changing. It will continuously change position. Did you see it? Just little displacement is continuously changing position. So we say it's neutral equilibrium. So don't forget that. Then the next thing we want to talk about is what is term center of gravity. What is the meaning of the word center of gravity? Center of gravity of a body is the point on that body where its resultant weight is acting at. Center of gravity of a body is the point where its resultant weight is acting on or acting at, is acting at. So thank you for that. Then the next thing we need to talk about is, so for you to get to the center of gravity of some shapes, there are techniques we use for getting the center of gravity of shapes. We can make use of, if it is geometry like rectangle or triangle, just get the diagonal of it. So the center here is the center of gravity. If it is a triangle, all you need to do is just bisect this side. When you bisect this side, you have a perpendicular line. You also bisect this side, you have a perpendicular line. So this point on it is the center of gravity. Another point is to use what we call just if you have another shape that is not a regular shape, it is very easy for you to get. So if I have a shape like this, and I need to get the center of gravity, all I need to do is just punch a hole at one of the ends So when I punch a hole at one of the end, then I will put a nail on the wall, put this hole on that nail, then I will put a plumb line, a rope that has a weight on it. So let's assume this is where I have punched, and I punched, so I will put the plumb line on it. So the point where this plumb line passed, I will note it. Then when I put plumb line on this point again, I will make it to stand vertically. Where it passed, I also note it. Then where the two of them intersect is the center of gravity of irregular body. So we can, for diagonal, for rectangle, we can make use of the diagonal. For triangle, we can make use of this. Then for irregular shape, we can use plumb line. This is how to get the center of gravity of a body. Get the center of gravity of a plane shape. So then next is the principle of equilibrium. So what are the principles of equilibrium? For a body to be in equilibrium, we say that it must not what? Rotate, and it must not accelerate. So if a body does not accelerate and if a body does not rotate, we say that body is in equilibrium. So that give room for the following to be the principle of equilibrium. Apologies, I did not know that it was not videoing again, so I had to just retake it. So I said this is how to get to the center of gravity of plane shapes. Then the next thing we're going to talk about is the principle of equilibrium. Principle of equilibrium, since we say for a body to be in equilibrium, it must neither accelerate or rotate. That is, it must not accelerate and it must not rotate. So that results into having two principles for a body to be in equilibrium. So the first principle is algebraic sum of forces acting on the body must be equals to 0. The meaning of this is sum of upward direction must be equals to sum of downward direction. Sum of upward force must be equals to sum of downward force. Implication of this is sum of upward forces must be equals to sum of downward forces. Number 2, sum of the forces acting on the right must be equals to sum of forces acting on the left must be equal to sum of forces acting to the left. So that is the meaning of this. Algebraic sum of forces acting on the body is given to be equals to 0, or must be equals to 0 for a body to be said to be in equilibrium. And sum of the forces acting to the left must be equals to sum of forces acting to the right for a body to be in equilibrium. The second part of the principle of equilibrium is algebraic sum of moments about a point. Algebraic sum of moments about a point must be equals to 0. About a point must be equals to 0. To 0. So that is, sum of clockwise moment must be equals to sum of anti-clockwise moment. Sum of clockwise moment. So I want to use this as sum of clockwise moment about a point must be equals to sum of anti-clockwise moment about the same point. Sum of clockwise moment about a point is equals to sum of anti-clockwise moment about the same point. That is just in summary, algebraic sum of moment about a point must be equals to 0. So thank you for watching. In the next video, we'll be talking about how to identify or how to resolve or how to interpret this question when you see it, when you see question that have to do with this equilibrium, or when you see some diagram and how to interpret them. You will see it in the next example. Thank you for watching. Stay tuned.